Good evening from Charlotte, North Carolina. I'm James Brierton, and welcome to a brand new episode of the Carolina Weather Group for this Wednesday, June the 9th, 2021. After flash flooding events this past week near Charleston, South Carolina, and Charlotte, North Carolina, we're going to be digging into and learning more about how the National Weather Service forecasts excessive rainfall events and the risk for flash flooding. And a reminder that you can check out this episode and more 24 hours a day on the all-new Carolina WeatherNet, streaming for free anytime on the Carolina Weather Group's YouTube channel. Check that out. And don't forget, as you're traveling, you can take us with you by checking out our audio podcast wherever you listen to podcasts. Okay, that's it from me. Let's hand things off to Scotty Powell and the panel with tonight's interview.
We're happy to have you this evening. We have with us Alex Lamers. He is the Warning Coordination Meteorologist for the Weather Prediction Center in College Park, Maryland. And the Weather Prediction Center does a whole heck of a lot in the weather community, from flash flooding to winter weather products and a little bit of this and that, everything else. So we're excited to have Alex on with us tonight. Kind of talk about the inner workings of the Weather Prediction Center, but we really want to focus on flash flooding. We know over the last several years here in the Carolinas, we've seen numerous flash flood events associated with tropical systems and just heavy rain events that's set up over the Carolinas. So we really want to focus in on that tonight and kind of talk about why we are seeing these events and some of the statistics that may kind of make you scratch your head and think, my goodness, I didn't realize that we had that big of a flash flood threat here in the Carolinas. So we hope you will enjoy this conversation tonight. Alex, I'll go ahead and bring you in. We welcome to you the program tonight. Since you're a first-time guest, and we're happy to announce that we are breaking Alex into the weather podcast world. So this is his first weather podcast. So we appreciate that. We'd like to know a little bit more about you, Alex. Tell us kind of the weather journey that you've been on from the beginning to now at the Weather Prediction Center.
Yeah, thanks. I'm glad to be here. Thanks for inviting me. I don't have really a one event that stands out. I know some people said I really got into weather because of a specific hurricane or winter storm. I think it was really because as a kid, I was really interested in aviation. Flew a lot on flights. My family lived in California, my immediate family, but a lot of our extended family was back in the Midwest in Wisconsin. So a lot of cross-country trips, flying over the mountains out west, got to see some cool cloud formations, and that kind of just naturally, one thing led to another, and I became interested in meteorology. And then decided to pursue it as a degree, went to the University of Oklahoma for my schooling, and then went into the Weather Service immediately after. Been at a number of locations in the Weather Service. So I've been in the offices in Milwaukee and Norman and Duluth and Tallahassee, and now I'm at the Weather Prediction Center.
Well, Alex, being at the Weather Prediction Center, could you tell us a little bit about what y'all do there and how you guys cater to the entire nation through all of your work?
Yeah, it's a really big mission. So the Weather Prediction Center, we're one of 9 specialized national centers in the National Weather Service. And I'm sure people are familiar with the National Hurricane Center, the Storm Prediction Center. We're one of those. And the idea is each of these centers provides a specialized expertise on weather-related topics. So at WPC, our bread and butter is really precipitation, extreme precipitation in that day kind of 1 to 7 time frame. And that includes both rainfall and winter weather. We've been doing precipitation forecasting since about 1960. And so it's a pretty long legacy here that's been passed down through the decades. But there's a lot of other stuff we do. We have OCONUS support. So there's an Alaska desk that provides support in the medium range timeframe for Alaska, medium range forecasting for the CONUS. We even have an international desk that's a partnership with USAID and the State Department, and they do training for visiting meteorologists from Central America, the Caribbean, and South America. And they produce products. You can find them on our website. They're kind of, training products, and they're used as guidance in some other countries as well. But that's kind of another cool facet. And they provide some support to our own meteorologists who are working the U.S. focused desks during tropical cyclones.
So, Alex, I think, people who've listened to this show, we've had various warning coordination meteorologists from a lot of local WFOs come through. What is the difference between a warning coordination meteorologist at the local level versus at a national center?
There are some similarities. So there's aspects of outreach and training. It's just, I'm not necessarily going to, the local firehouse and giving a Skywarn talk like a local WCM might, but I might be stopping by a FEMA office and giving them training on tropical cyclone rainfall, for instance. So there's interaction with our core partners in the Weather Service. There's interaction with members of the general public too. And there's also a coordination aspect across the Weather Service. And I do consider, other offices in the Weather Service one of our key partners. So really staying in touch with those local offices, some of our regional offices, and working together on, anything from policy on specific products to forecasting challenges, reviewing big events, that sort of thing.
Let's talk about the product itself, what we see on what we pull from the internet, what we pull from your website, and use all throughout our forecasting efforts. We talk about QPF, which for the public is Quantitative Precipitation Forecast. Tell us a little bit about that. Like, what goes into this product and where's the data coming from? How are you generating these maps that you show?
That's actually the one I was referring to that we've been doing since 1960. We actually have verification charts on our website that go back to 1960. So those forecasts are for liquid equivalent precipitation. And obviously that has implications for winter weather just as much as it does for a landfalling tropical cyclone. We're basically trying to forecast the amount of precipitation that will fall. And the intent is for us to forecast the precipitation kind of in a big picture aerial average sense. We know we're not going to hit every little max and min here or there, but to give a good big picture. And a key user of our precipitation forecast is the river forecast centers in the Weather Service. So they like to have continuity with the general areas of precipitation that we're forecasting. They don't like the maximum to jump from basin to basin real wildly from shift to shift. To provide, good continuity with those river forecasts that people rely on. So we tend to approach it from a big picture sense. And overall, if you look back over the decades, the skill of our precipitation forecast has improved about a day a decade. So to put that in maybe easier to understand terms, a day 3 forecast today is basically as skillful as the same day forecast was in the late 90s. So it's been a pretty steady improvement. There actually, the rate of skill improvement has increased since about the modernization here in the Weather Service, or that was in the early to mid 1990s. But that's good. We like to see that. And a lot of that is due to improved numerical weather models. We use a lot of that guidance as the basis for the forecast. Nowadays, we're kind of blending those models in a software program. In the past, our QPF forecast might have actually been hand drawn on a map and that sort of thing. So a little bit different, but the legacy is there, and it goes back, pretty far in the Weather Service's history.
How is it relayed? Is it we go out, we have day 1, we have 1 through 3? I mean, how are we putting this out? Does it go up to a week?
Yes. So we produce our precipitation forecast out 1 week. And the forecasters are basically doing those in 6-hour increments. So every 6-hour block of time, they are evaluating the situation in that time frame and making adjustments as necessary. And I'm glad you brought up WFOs, because that is important. We do have a pretty significant coordination aspect. So we are doing a lot of work, especially in the last few years, of getting this process improved in how we're working together on the precipitation forecast. The goal is to have one Weather Service precipitation forecast that you would get the same thing as if you go to a WFO as you do if you go to the WPC webpage. So there's some behind the scenes kind of improvements that are being made to that process now. And I think we've made big strides on that over the last decade or so. But really every day, our forecasters and the forecasters at every local office around the country are talking constantly about these changes. And we're relying on their local knowledge, what they might want to see, and they know what they're talking to their partners about in terms of local concerns as well. And they're relying on us for some big picture stuff like model biases in certain situations and that sort of thing, because every day we're doing precipitation forecasts across the entire country. So we get a lot of at-bats on that, and we get a lot of the ensemble model data that we pour over every day.
Any special circumstances where you might update more than twice a day?
Yeah, I mean, we have the ability to update unscheduled. It doesn't happen too often. The update cycle tends to be tied to the major model cycles. So the 12Z models come in, we run the forecast, and then that gets sent out. Same thing overnight. And it kind of matches those big forecast cycles from the local offices as well. I'm sure if your listeners are used to digging into the forecast details and they like reading like the area forecast discussions, they're used to seeing that kind of mid to late afternoon time frame, and then the early morning hours when updates come out. It's about the same for us in most situations.
Excessive rainfall outlooks, that's another product that a lot of people are familiar with, especially within the weather community. And I think a lot of private sector meteorologists also try to communicate those. I think of TV and how when you guys issue an excessive rainfall outlook, it gets communicated to the TV world and gets dispersed from there. Can you tell us a little bit about what those outlooks are and what goes into making the decision between a slight risk and a high risk?
Basically, it's an outlook that's trying to describe the risk of rainfall that may lead to flash flooding in your general area within 25 miles of a point. That's what the probabilities are. So it is sort of like the Storm Prediction Center outlooks, if people are familiar with those. They have the same sort of probability definition in that those probabilities you see, those are within 25 miles of a point. So let's say there's a slight risk. That's like a 10 to 20% chance of rainfall that might cause flash flooding within that area. And if you look at a map and you look at like Raleigh, for instance, you draw a radius of 25 miles around the city center, it's roughly going to encompass that whole metro area. So if you're sitting in Raleigh, there's a slight risk. It tells you on that day in that metro area, there's about a 10 to 20% chance of flash flooding. So that's how we get those probabilities. What goes into making the risk determinations, it's a lot of different factors. I think back to the old Doswell 1996 paper about flash flooding, which, to paraphrase, he basically says, well, he does say it's an almost absurdly simple concept, and that the heaviest rain will fall where it rains hardest for the longest time. So there's an intensity component and there's a duration component. And the intensity component, the high resolution models that we use are getting better and better at capturing some of those really intense rain rates at the hourly, 3 hourly, 6 hourly time scale. Really where we have some chance to grow in the near future, I think, is with sub-hourly rainfall. And the latest upgrade of the high resolution rapid refresh, HRRR model, the latest version of that has 15-minute rainfall information in it. That's actually really cool to see. And that can be super important for burn scars out west, the sub-hourly rainfall rates, as well as in urban areas. So we're looking at that sort of real short, high-intensity rainfall, what might lead to a large runoff response. We consider the general meteorology. So I know, for instance, when the Storm Prediction Center puts together their outlooks, they're looking at typical ingredients, the instability, is there going to be wind shear, that sort of thing. We're looking at similar types of large-scale pattern. And then also there's vulnerability underneath that. So The product that we do look at flash flood guidance for that. That gives you kind of an estimate of the rainfall that would be required to cause flash flooding. But generally speaking, you look at an area, is it in droughts? Has it been really wet for the last several weeks? That's another thing that we look at. So there's a lot that goes into it. And it's another product that's coordinated with local offices.
You guys also issue several different risk outlooks in terms of from slight all the way up to high. With the high risk, obviously that's the highest on the chart. But those high risk days account for 9 out of 10 flood related damages and 2/5 of all flood related fatalities. So it's clear that high risk days need to be taken seriously. Obviously, all of them are serious. Even a slight risk needs to be taken into consideration each day. But can you talk about high risk days and how the public can prepare for those if they're in a high risk?
So we look back at days in which a high risk was in effect, and we didn't necessarily limit our search to just events within that high risk area. Because one thing to communicate about these risk outlooks is even on a big severe weather day, for instance, you don't necessarily have to be in the high risk area if the signal is there for an outbreak to have a bad day. It's similar. I don't think we really use the phraseology of flood outbreaks, but similarly, you wouldn't necessarily need to be in the high risk. So we looked at adjacent, slight, and moderate risk areas as well. But when a high risk is in effect, those days, there about 90% of U.S. flood damages occur on those days. And about 2 out of every 5 flood fatalities occur on those days as well. And that's important because they're relatively rare. It's about a dozen or so days per year that we would have a high risk in effect. They're a little more common on the excessive rainfall outlook than they are from SPC for severe weather outbreaks. But yes, because of that research, we've kind of started pushing or branding them as potentially damaging and deadly days, just for people to raise awareness that they need to be thinking a little bit more about their particular vulnerability and risk, and maybe change their usual routine on those days. And our verification statistics show that those risk categories are calibrated. So it's a probabilistic outlook, and it's so moderate risk, that's like a 20 to 50% chance. Well, about 40% of the time in those moderate risk areas, there is flash flooding within 25 miles of a point. So it is fairly well calibrated. And so, when you look at this research that says, yes, there are huge impacts on high risk days, and yes, we are calibrated, there is skill in actually identifying them, then you start to think, what should our message be to the public on those days? Should you be out driving on the road? I mean, when you think about it, to about 2 out of every 3 fatalities related to flooding are related to vehicles. So, I mean, it's definitely, if you are, let's say your commute to work takes you through low water crossings or through an underpass that, just in the back of your mind, like, yeah, that place usually floods. I see water under there all the time. It might be those days where you say, if I have the ability to work from home, maybe that's a good thing to do. If I can adjust my commutes, give myself more time, or maybe plan for alternate routes, that's another good thing to do. I think just equipping people with those short little nuggets of things that they can do on those days be really helpful. But there are certainly days we want people to be paying attention to the potential for serious flood impacts.
Well, Alex, I have a deep question for you, and feel free to answer as little or as much as you want to. Obviously, over the last several years, we have seen the magnitude of heavy rain events continue to increase. It seems like there's yearly, we had 5,000 or 1,000-year floods, 500-year floods. We're starting to see these floods occur more and more on a frequent basis. Why is that? Why are we starting to see these heavier rain events happen? It seems like every month or so.
There has been an uptick in the frequency of extreme rainfall events. There's a number of different ways you can define that, whether it's the 95th percentile events or 99th percentile events, or There's a number of different ways you can look at that, but if you look at the National Climate Assessment, and this has been actually pretty consistent in the last several assessments that we've issued, that the heavy precipitation events in most of the United States have increased in intensity and frequency since we got into the 20th century. And there are regional differences. I think the bigger increases that you've seen tend to be in the eastern half of the country, particularly the Northeast, but the Southeast and up in the Midwest as well. The basic principle there is warmer air can hold more water. I mean, if you think about it, that's why when you're in a winter storm, you're not getting 30 inches of liquid equivalent. I mean, that would be mind blowing, right? You'd have 300 inches of snow. That's crazy. Because that colder air can only hold so much water. It's also why when you have a winter storm, if you look at the vertical profile of the atmosphere and you have those deep isothermal layers that are almost at the freezing point, but they're not quite. So if you look, there's several thousand feet deep, you can really get very heavy snowfall and a lot of liquid equivalent from those storms because on average, that profile of the atmosphere is warmer than a cooler profile. So that's the basic principle. Not an expert on the nitty gritty details of that necessarily, but that's one aspect. The other thing to consider, I think, in terms of people are like, wow, it just seems like, I'm looking at the news these days and, there every few weeks or month or so, there's these pictures of, lots of flooding. So there's what's going on in the atmosphere. Then there's also development patterns. I mean, that plays a role, right? If you have cities growing outward, and Stephen Strader, somebody that I follow on Twitter, he's a good follow. If you like to think about weather-related risk and disaster-related risk, he has written, and Walker Ashley, I believe, too, about this expanding bullseye effect. And it comes up with respect to tornadoes. If there's bigger cities, tornadoes that in the 1950s may have kind of passed through the woods more, may be hitting suburban areas now. Same thing, if you have a lot more impervious surface on the ground, then that may change the runoff patterns. It may change the way that people are affected, how people commute. I think society tends to evolve in these ways, and so people will be dealing with these challenges, but development patterns play a role in terms of the actual impact that you get from rainfall as well. So, over a metro area, it could be that in the 1950s, maybe it wouldn't have had as the equivalent amount of rainfall back then, maybe wouldn't have even had quite as much of an impact as it would today, just given the amount of, roadway and impervious surface with concrete and stuff we have now.
Talk a little bit about your challenges with some of these large, massive rain events that are triggered by different systems.
It is a big challenge. I think one problem is there's different scales, right? You're talking about a Harvey or a Florence, and you have heavy rain over a huge area. Then you look at something like Ellicott City, which is a particularly vulnerable basin. And it was really high intensity rates over a very small amount of time. And actually in the 2016 event, I think there's a rain gauge in Ellicott City or somewhere near there, certainly within the basin, that had just over 2 inches of rain in 15 minutes, which is crazy. So you think about that and those short, high intensity bursts of rain. They even show up in some tropical systems as well. If you go back, I think Harris County, Jeff Lindner down there, they produced a good report of the rainfall from Harvey. And if you go look at the rates that are down at that 5, 10, 15-minute time scale, they're pretty crazy. And understanding those in those vulnerable areas and basins, I think, is an area we really have to grow in our expertise. I think there's good opportunities for research there. And like I just said, the flagship high-res model for the National Weather Service did recently add that 15-minute rainfall information. And I will say we do have a test bed at our office. So similar to what you have in Norman with the hazardous weather experiment, they evaluate experimental severe weather products. Our test bed up in College Park is focused on extreme precipitation events. So this is the sort of thing they'll look at, that sub-hourly rainfall information. I think another big challenge is probably, how confident are we that duration of heavy rain is going to be maintained? Because remember, I said it was an intensity and a duration thing. And you get these cases where things are moving slowly, but they're moving, right? There's maybe like a 5 knot or 10 knot drift to things. So if you have a band of rain, you're going to get heavy rain, but it's going to move off of an individual location after an hour or two. Then there's cases where it's almost like a fire hose. You mentioned the 2015 case where you're basically siphoning moisture off Hurricane Joaquin, deep plume of moisture, and it just kind of stayed in place for a long time. And I think being able to differentiate those subtle differences in the flow, that's a big thing. But the model's been getting better and better. I think understanding what they're producing, their strengths and weaknesses, and the ensemble probabilities that we're now getting, which are very powerful. Those are all useful tools in our toolbox. But it is often a very fine line between, like I said, something that has a very slow drift and something that's stalled. And that's an important difference and distinction to make.
Well, Alex, thank you so much for that information. Great information. And we hope that our listeners and those who are watching kind of take this threat serious and really pay attention to those outlooks as we enter the more flash flood season with spring and summertime and those tropical systems. And there's those heavy thunderstorm days where we get 3, 4, 5 inches in one setting. So, Alex, if anyone wants to follow the products, I know you have website, social media. What's the best way to get the information?
Yeah, the Weather Prediction Center website. It's a good resource. We're on Facebook and Twitter as well. Just if you search for Weather Prediction Center WPC, you'll probably find it. Those are probably the best ways to get, the latest and greatest from what we're doing. I think I'd like people to get in the practice of, for instance, checking the excessive rainfall outlook as much as they check the convective outlooks and the Hurricane Center webpage. And we've been partnering, for instance, with the Hurricane Center more and more. So now if it's a tropical cyclone, you get those rainfall maps, you get the ERO maps right on the Hurricane Center webpage. Now you don't have to actually search for them. So, but WPC website, that's a good place to start.
All great information. I know that all of us here on the panel uses, and we encourage you to do that as well. Well, Alex, appreciate your time tonight. And thank you all for watching and listening to the Carolina Weather Group. We'll see you back here real soon.